If you had a mathematical dictionary and you open up the dictionary and you went to the word velocity, what would it say? It would say that velocity is the rate of change of displacement. Think about it, right? So miles per hour, miles displacement with respect to time, hours, or meters per second, meters with respect to seconds, right? So in other words, you would see this. And this makes sense, okay? Because if you think about a random displacement time graph, or you can think about a distance time graph without the negative numbers, right? The gradient gives you the velocity, right? Gradient is the velocity, you differentiate the displacement over time. So as an example, right, let's look at 5 seconds. So 5 seconds into the journey, I don't know, the gradient looks like -3. So the velocity at that point in time in the journey is -3. So I'm going to take this definition, I've just written it out here. So V for velocity, S the displacement. In A level, you tend to use S for displacement. When you go to uni and you do physics and maths at uni, you will use X. That's the letter they tend to use. So the idea now is you can times both sides by this dt. So in other words, the velocity times a small change in time is equal to a small change in displacement. Now, if a small change in displacement is equal to the velocity times a small change in time, if we want to create the entire displacement, we need to add up all of these small changes in displacement. So we add up all of these ds's, and the mathematical way that you do that is you just bang in an integration symbol. So put an integration symbol on both sides, which just means add up these small changes. And so that means the displacement of a journey is the integral of velocity with respect to time. And so that is the precise reason why when you have a velocity time graph, to get the displacement, you work out the area under the curve. And that is the precise reason why. So again, your displacement is equal to the area under this curve, the integral of velocity as time goes on. So now sticking with this velocity time graph, let's think about the gradient of a velocity time graph. Now again, imagine you had a mathematical dictionary. What would it say for acceleration? Acceleration is the rate of change of velocity. So in other words, velocity per time. So in other words, meters per second squared, for example, which just means meters per second, or could be kilometers per hour squared. So in other words, kilometers per hour, right? So in other words, acceleration is d velocity with respect to time. So here's a good example, right? So at this moment in time in our journey, we've come to this position here. The gradient there is 0, okay? No gradient, the gradient is 0. So that tells us that the acceleration is equal to 0 because the gradient of this velocity time graph is 0 and differentiation gives you gradients. And again, with this equation here, we can times both sides by dt, which again means a small change in time. So we have a dt is equal to dv. And now again, we can add up all of these small changes in velocity to create the total velocity. So in other words, integrate. And so what we get is velocity, so this thing there, is equal to this thing. So the integral of acceleration with respect to time. So now what does that mean? Well, it means if you have an acceleration time graph, then the area trapped between the curve and the x-axis is going to be velocity. So the integral of acceleration as time goes on. So the area under the curve, or it could be the area here, right? So this is the thing with acceleration, velocity and displacement. They are vectors, which means they can be negative, which is why I've drawn a negative y-axis here, a negative y-axis here, a negative y-axis here as well with displacement. So what I've done here is I've just drawn some random graphs, so a velocity time graph, an acceleration time graph. Now, as we should know, speed is a scalar, velocity is a vector. So what if we had to use this graph to now go and draw a speed time graph? So what you need to understand is that speed is the magnitude of velocity. So in other words, it is the modulus of velocity. So we want to sketch the same curve for here, and then we just reflect this upside down because we're not allowed negative speed. Speed can't be negative, right? Speeds can only be positive, but obviously velocities are vectors, they have direction, which is why these velocities can be negative. So our speed time graph is going to look something like this, okay, where these negative velocities, so in other words, the speeds we have when we're traveling backwards. So at this stage of the journey, we're moving backwards, but of course you can't have negative speed, so we just make those speeds positive. So again, it's a really similar thing with this graph. If you want to sketch magnitude of acceleration, so again, acceleration is a vector, you can have negative accelerations, right? These are decelerations down here. Again, it's really similar to this, right? Magnitude of acceleration is just the modulus of this here. So just reflect this graph the negative part of this graph. So again, with this one, something like this. Now what I'm going to do, I'm just going to pretend that this area 1 here is the same as this area 2 there. So in other words, the area 1 there is equal to the area 2 there. They're both the same size. Let's just pretend the areas are the same. Now remember, the area under a velocity time graph is displacement. So what's happening with this journey, as time goes on, we're traveling with a bigger displacement, we're moving forwards. So imagine us walking or driving a car, right? So we're driving forwards, keep on driving forwards a little bit more. Now, once we hit here, this middle part of the journey, notice that the velocity here is 0. So in other words, the speed is 0, so we're not moving. At this point, we're stationary. So we've driven the car forwards, we're driving forwards, and then now we've stopped, we come to a standstill, and now we're moving backwards. So we're moving backwards now because we now got a negative velocity. Negative velocity means we're turning back on ourselves and moving behind us. So we're turning back on ourselves, we're driving back further until we get to here again when we're at a standstill again. Now, because area 1 is the same as area 2, that means that the distance travelled in this part of the journey is the same as the distance travelled in this part of the journey. So in other words, we've walked forward, for example, 100 meters, and then we've gone back on ourselves 100 meters. So at this moment in time here at the end of the journey, we're back to where we started because the distance forward is the same as the distance behind us. And again, we can see this here, right? So we've traveled forwards, right? That's our distance forwards. That's our distance backwards. So the distance traveled is double this one because they're both the same. So again, let's just say that that area there is 100 when we integrate this, and when we integrate this part of the curve from here to here, let's say we get minus 100. So your total displacement is 0, right? Because you've ended up back where you started. However, your distance traveled is 100 plus 100. So you've traveled 200 meters, but because you got back to where you started, your displacement is actually 0. So hopefully this makes sense, and hopefully you can see the difference between speed and velocity and displacement and distance traveled. Now let's take a look at these acceleration time graphs here, right? So what I've just said here, so remember we said that the area under the curve is speed or velocity, right? So I've just said here that this area 1 is 200 meters per second, right? So the velocity in this part of the journey is 200, and let's just say that this area here is 150. So they look a bit different, so I'll just call this one 200, I'll call this one 150. Now what I'll do, just to keep track of the times, I'll call this 10 seconds, I'll call this here 20 seconds. So again, I'll do the same with this graph as well, 10 seconds, 20 seconds. So now back to the acceleration time curve, let's move along the curve. So as time goes on, right, the acceleration, as we see, is getting bigger, still positive. So that means that the velocity is increasing, right? Because again, the area is the velocity this time, right? So the area is getting bigger, velocity is getting bigger, still getting bigger, even though the acceleration is now starting to decrease a little bit. Okay, it's decreasing now, right? The velocity is still getting bigger. Notice how the area of these bars is getting bigger, right? Velocity is still getting bigger and bigger and bigger and bigger and bigger, and now we've hit this point here where the acceleration is 0. So again, in other words, when you integrate this acceleration with respect to time from 0 seconds up to 20 seconds, we would get, in this instance, 50. Sorry, that 5 is dreadful there, sorry about that. 50, so 50 meters per second after 20 seconds. So that there is our velocity at the end of the journey, and because this velocity is positive, it's the same as the speed, okay? So it's the same as the speed. Now, some of you may be wondering, well, wait a second, what if we do 200 plus 150? That gives us 350 for this magnitude of acceleration curve. Surely the speed would be 350. Well, no. I mean, if we go back to this speed time graph we had before, right? The reason we added these two areas together to give us 200 is because this was the total distance traveled. And sometimes in life, we do care about how much distance we travel in a journey, right? So sometimes we want to know what was the total distance of our journey, even if we are going backwards. Now, in this case here, with this magnitude of acceleration curve, the problem is that when we do 200 plus 150, this gives us the sum of the speeds. So it gives us the sum of the speeds in these two parts of the journey. Now in life, do you really give a damn about the sum of the speeds you've traveled? Not really, right? You give a damn about what your final speed was, and your final speed was 50, right? Now if this was a negative number, obviously you just make it positive to give you a speed, because speeds must be positive, but you just give a damn about your speed, not the total speeds that you traveled.